Hey guys, hope you're doing great. This is lecture 4 of the video tutorial series on Scilab and Xcos. So where we left last time, we got to explore a bit of the code editor as well as the console. So just to brush up, this is how we define a 1D matrix, linearly spaced points. We start from the point we want and the last point we want to end at and the number of points in between. Let's say I want to divide it into, I don't know, 40 values. So yeah, this is how we're gonna get it. Um, Now some operations, if I do this, okay, let's take a more manageable matrix. Let's take x equals lin space 1 to 5 in steps of 5. So we want 5 points, right? So in order to square, we just raise it to the power. This exponentiation operator is for raising it to the power of. So we can square it, we can cube it, yeah, likewise. The first thing we need to know is how to transpose a matrix. So as you can see here, x is a double matrix of a type 1 cross 5, which means it's a single row 5 column matrix, which means it's a row matrix. If we want to convert it to its transpose, which will be a 5 cross 1 matrix, which will be a column matrix. So we just follow it with the single code. So that makes a matrix which is the transpose of the original matrix. Right? So we need to do transposition a lot of times in order to make them compatible for multiplication. So that's just one of the things I wanted to show you. Now okay, so one of the useful things you need to know, if you need to clear the console, you just type CLC, which stands for clear console. Right? If you want to clear the variable browser, just type in clear, then CLC. Okay. So I wanted to briefly introduce you to the graphical window as well. There's another window beyond the ones you see on screen. So for that, let's define x. Let's say these are degrees that we're defining. Let's say from 0 to, actually let's start from 1 to 720 degrees, 2 cycles, and we want 720 points. Okay. Now let's define a constant so that we can modulate. Let's say 0.75 of x. So A will also be a row matrix, right? Where each element of x will be multiplied with 0.75. So it will also have 720 elements, right? So let's say we want to plot a function y, which is the multiplication of A as the factor which comes outside the sign term. So A, but since we're multiplying two matrices together, if you want to just multiply the first element of A with the first element of x and the second element of A with the second element of x and so on and so forth, we need to calculate the dot product, the scalar product. So this is how you add a dot product, right? So just write a dot followed by the multiplication term, and then we take the sign d of x. Why d? Because of the degrees, because we've defined x in degrees, right? So, and if we wish to plot it, we just write plot and the variable of interest to us. So right now we're going to run this while saving it. So you see, it's 2 full cycles, but also at the same point of time their amplitudes are being modulated with respect. So as you get farther in time, their amplitude increases. So this was a basic demonstration of the graphical window. So the graphical window, like all the other windows, can also be brought onto the dock if you wish, right? So we'll get into the graphical window a little bit more in the further lectures, but this is all I had to tell you. And okay, right, so another clear figure function is CLF, where the graphic window is reset. So these functions are generally all used at the beginning. So you clear console, and then you're ready to go. Okay, thank you for watching.